One of the most common terms used in chemistry and physics is energy, and I wanted to give a brief supplementary video on exactly what energy is. One of the fundamental definitions of energy given in every introductory physics course is that work is equal to a force being applied over a distance, and work is a type of energy. Using this definition, we can calculate the energy of moving a block over some distance by measuring the force used to move the block, using its mass and acceleration, as well as the distance it moved. Using this definition of mechanical work, we can then apply it to lots of systems, such as pressure chambers expanding and contracting, blocks falling through the air, and other mechanical systems. We then can expand this to electrical work using forces between charged particles. One of the fundamental aspects of energy is that it is conserved. This is actually one expression of the first law of thermodynamics. This makes solving lots of problems in introductory physics much easier, as instead of dealing with forces, one can use the conservation of energy. One way that energy is conserved is by converting potential energy into kinetic energy and vice versa. For example, if I raise a block up a certain distance, I had to do work to do this, or I put potential energy into the block. If I then drop the block back to its original position, this potential energy is converted into kinetic energy. Kinetic energy of a body is defined as 1/2 the mass of the body multiplied by the velocity of that body squared. Using the definition that momentum is mass multiplied by velocity, we can rewrite this as kinetic energy is the square of momentum divided by 2 times the mass. This is used to describe moving objects, and in chemistry we use this type of definition to describe kinetic energy of particles such as molecules or electrons. If I have a collection of gas molecules, for example, the total energy of that collection of gas molecules can be calculated by knowing the momentums of all of those molecules. One of the breakthrough experiments in physics was showing that heat was an alternative form of energy. James Joule showed this by converting mechanical energy into heat and showing that it was conserved. One interesting aspect about heat is that all energy can be completely converted into heat, but the reverse process is not true. There are devices called heat engines which convert heat into mechanical work, but there is always some amount of energy that cannot be completely converted into mechanical work. Soon I will do a video on the Carnot cycle and the maximum efficiency of a heat engine. Of course, there are many more forms of energy that I have not touched on. For example, there's nuclear energy, the energy which binds nuclei together, energy in chemical bonds, which is a form of electrostatic energy, or Einstein's most famous equation relating mass to energy. However, for our purposes in thermodynamics, all of these types of energy can be lumped together. Thank you for watching this supplemental video on exactly what energy is. If you enjoyed this video, please like and share this video as it helps considerably in increasing outreach. If you want to see more videos on chemistry and physics topics, please consider subscribing to the channel. I have linked my Patreon page in the description below. And if you would like to support educational content like this, please consider donating. Finally, please comment down below if there's something you feel like I could make more clear, or if there are other topics that you would like me to cover. Thank you.